we also used to have some software engineers in our team, to manage a couple of the tasks. And that team was quite big. It was about a team of 20-25 people. Now it has cut down to 2 people. And it's just a bunch of softwares that we are running. We are pushing on the chips, and the chips is giving the out. Now the push has that software has to run on some hardware, on some real hardware. So that's where we see an exponential increase in the requirement of hardware engineers. Students B.tech with a B.tech qualification, and spending about 9 months to 10 months in the area of semiconductors and VLSI. Their starting package is about 20 lakhs per annum to 22 lakhs per annum. That's the range that we have seen in India.
Hello and welcome to another episode of IEEE Pune's podcast, Beyond Conversations. Our guest for today is Kunal Ghosh. Kunal is a co-founder of the semiconductor EdTech company VLSI System Design, a platform to educate students and young professionals to build careers in hardware engineering. The company was founded back in 2011, a brainchild of Kunal and his peers from IIT Bombay, where he pursued an M.tech in VLSI and microelectronics. Kunal has been working in the VLSI and hardware design industry for more than a decade, taking on the role of physical design engineer at Qualcomm and lead application engineer at Cadence Systems. In this episode, he speaks about what it takes to bridge the gap between academic instruction and finding your break in the physical design industry, effective strategies to crack a hardware engineering interview, building impactful projects, why and where to pursue an MS or M.tech in hardware, and more. Good afternoon, Kunal. It's really great to have you as a part of the IEEE Pune podcast show, Beyond Conversations. Let's start talking about the field that you're working in. So today we see that there are so many students who want to be engineers, but their first choice is always that they want to be probably a software engineer, a computer engineer. And there isn't a lot of thought into probably going into some of the hardware domains. Although we see that there is a boom in the chip making industry. So what went through your head when you were deciding that you want to work as a physical design engineer? And what opportunities do you see today?
So actually, it all started, I would say, 2004-5 onwards, when my dad actually took me to one of the Reliance Infocom centers in Ghansoli. It's in Mumbai. So I used to work with all those systems and all, and I was an intern also at Reliance Infocom, where mostly we were working on some communication database systems. So we worked on all of it, and that actually got me into hardware, actually, not chips yet, but hardware. So that's where I was an intern at Reliance, and there I used to work with a lot of systems and everything. So that got excited me about hardware. Then did a lot of work in the hardware domain, in the embedded space domain, and that's when it got really excited me into chips. Because finally, when we look into embedded, it's just a bunch of softwares that we are running. We are pushing on the chips, and the chips is giving the output. So what really gets inside the chips, that is what really got excited to me. Then we started exploring semiconductors while I was in 2006, 5 or 6 sometime. We had a course in semester 5 or semester 6, which was in microelectronics as an elective. And 3 or 4 students were the only ones who chose that particular subjects, and that was very fascinating. And microelectronics or VLSI are mostly people who love physics a lot. There is a lot of physics involved. There is a lot of device physics involved, and that is what is the and then you need to be really excited about electrons, protons, and those kind of fundamental topics that again comes from your background. So my background as after 10th, after my SSC, was computer science. And computer science, there was a special course. It's in diploma. Generally, we talk about there are no non-relevant subjects in diploma. Electronics and telecommunication. I did my diploma in electronics and telecommunication, and there it was mostly about it was called computer science, but there was mostly digital electronics, the Q basic, and all those topics that was there at those days. So it was always hardware, it was always physics, as a part of my 10th and 11th and diploma, and that's what I continued with. So it's all connected to the roots. That and my dad is a hardcore electrical engineer, so he's also into physics. So it whole chain was into engineering and physics. So that is actually runs in the blood. So that's what got me excited into every detail from electrical to electronics to chips, and now basically I'm a associate designer in the company which I'm working on.
That's very interesting to hear.
Yeah.
Having spoken about this, what do you think are the opportunities that are available for students today? The career opportunities that you can see in terms of being a hardware engineer.
So currently, pre-pandemic and post-pandemic things have changed a lot. Or in fact, pre-Chat GPT and post-Chat GPT, things have changed drastically. In fact, I'll tell you our example where now we used to, we also used to have some software engineers in our team, to manage a couple of the tasks, and that team was quite big. It was about a team of 20-25 people. Now it has cut down to two people because these two are now able to write codes, write softwares in a much more efficient way compared to those 25 clubbed. So things have changed post ChatGPT or post AI. Things have changed a lot. Now you can write software in few seconds. Now the push has that software has to run on some hardware, on some real hardware. So that's where we see an exponential increase in the requirement of hardware engineers. And now we don't push people to go for software only or go for hardware only. The trend says that there will be a lot of push on the hardware, but again, if you are not really curious about hardware, curious about the electronics and all, it is very difficult to sustain the field because it's not easy. It's a very hard field. For example, if it takes 3 months for you to prepare for a software job, it will take 9 months for you to prepare for a hardware job, for a semiconductor job. And but the difference what I have seen in my students was that 3 months doing a software training, they start getting the salaries very soon, within a span of 3 months. But in semiconductors, you have to actually stay at least for 9 months to get your first check. So that 6 months is what plays the real game, and whoever is able to sustain that 6 months of task, I think they fly. So salaries, I don't know about the software, but what I've heard, for a B.tech computer science engineer, about 3 months of software, good amount of software training, they get paid close to 30,000-40,000 per month, or max I've seen 50 to 80,000 per month as a part of the software engineer, which goes to about 12 lakhs per annum max. So for the B.tech engineers, for semiconductors, we have seen students B.tech with a B.tech qualification, and spending about 9 months to 10 months in the area of semiconductors and VLSI. Their starting package is about 20 lakhs to 20 lakhs per annum to 22 lakhs per annum. That's the range that we have seen in India. In US, it's even better. It's about 120K to 150K US dollars. At least the students whom I am talking about, whom we have group. So that's their starting salary. So the salary comes in, but it comes in a little bit late, in compared to software. That is the second motivating factor for participants or students to join semiconductors. But the first is always, you have to love electronics. You have to love physics and all. That's the main part. So that's what keeps you going.
We'll come to your journey as an educator later, but I think one of the points that you spoke about, preparation. So
Yes.
it takes a lot more preparation in
Yes.
order to get into the hardware industry. Firstly, so what can you tell me about what was your concept, or what was your idea of preparation? Since you've worked in both Qualcomm and Cadence, so what did your preparation look like, and what do you think is the preparation expected today from a student who wants to journey into this industry?
So 2010, when I was applying for all these companies, there was a lot of placements companies who came to IIT Bombay. It actually starts from December 1 to December, and it goes from December 10th. there are close to 40-45 companies which come to which came during those days. So being my background as core technical, and I was not much into aptitude. I was not much into. So there are problem statements, like there are word problem statements, so like A is the father of B, B is the father of C. So what is the relationship between A and C? Those kind of word problem statements also comes as a part of your written test. So almost all out of all the 45 companies who came to recruit, close to 42 43 companies asked that kind of questions as a part of their the written test, and I almost failed for all of them. And then I didn't clear the written test for almost 43 companies, just because I was not able to solve the word problems. The last two companies, there was one more company, and there was Qualcomm. Qualcomm and this company were the only ones whose question paper was fully technical, and that's where I cracked that thing. The written test is something which I was lacking during those days, because being core technical and not focusing much on the word problem statement. So Qualcomm had the question paper about Zener diodes, about transistors, all about technical. So that was the only paper which I was able to crack. That was the only company that I was able to crack the technical interview. So as long as it is technical, your core technical is strong, there is a company who's looking for you. I prepared only technical. The aptitude was something, either it comes by naturally, but for some reasons it didn't come to me. But typically it should come naturally to all the students who are looking forward for, because unfortunately, that is a part of your written test. Our written test, what when VSD looks for students or participants to work for our companies, we look pure technical. It's only technical coding and something that we look for. In fact, many companies are now adopting to looking only for technical skills, but there is a system in place for the other companies where they have to look into an aptitude for screening process. So aptitude, I cannot say much on aptitude, because I myself was not good at aptitude. But technically, you have to be super strong. Nobody should be able to challenge you on the technical side. So once you have that core strength, I think you have a long way to go.
Right. So in the recruitment season, I myself have appeared for many tests and for many companies. So one of the aspects that we as students try to perfect is doing relevant projects for that specific company. While for software,
Yeah.
it's quite easy, because you see that there's so many resources on the internet where you can see that, this is the kind of project that you could make for this specific domain. For hardware, it's not that simple. So what kind of projects would you suggest students to do if they're looking for recruitment to a hardware engineering domain?
Yeah. So specific to semiconductors, there is right now the state of semiconductors before and today, it's quite different. Right now we have a lot of open source EDA tools, which can serve as a starting point to at least to know this industry before even joining any of the institutes, or before even joining M.tech, for that matter, for VLSI. There are a lot of open source EDA tools, a lot of platforms, including ours, available for all the students, free of cost, just to analyze whether you're really you really like this particular field or not. So pre chat GPT and post chat GPT, or in fact pre-pandemic, post-pandemic, a lot of things have changed. And today you have a lot of materials on hardware as well. You can refer to our website, or you can refer to, if you can just search for also open source VLSI EDA tools, you'll get a lot of materials for all of you to test out and see whether this field really excites you. Then you can move to the expensive. You can spend your time on the 8 months or 9 months of time preparing for the bigger roles. But just to get the interest in this particular field, I think there are already a lot of resources available on Udemy, on Coursera, YouTube. You will find all of them.
Okay. Moving on to your journey as an educator and as an entrepreneur, when did you start? When do you think of starting VLSI design systems courses? Where did the idea come from? And I've seen on your website that approximately more than 90,000 people have taken your course. So where did this idea come from, and how did you build your platform for educating young students?
Okay, so teaching has always been there with me since I was in fifth standard. I used to teach my cousins. I used to teach my friends, and that thing was already there. Teaching in a most unique and innovative way. That was already there. When I joined, I'm a 2010 pass out from IIT Bombay, and that during those days, even me and my friends were looking for some content that could help us elevate or rise up in the industry. So industry and industry works on totally different, totally different level. The starting point is a very different level, and the level at which we closed our graduation and post graduation, there was that gap which was already there, and we ourselves were looking to trying to fill those gaps, and whatever content at that point of time we found, those were not very much structured. Since I started teaching like fifth standard, sixth standard, seventh standard, I used to teach my peers. Our platform or our content was always structured. That structuring was always there in our head. We have to present our content in such a way that it's very much clear. A lot of images, and it's very much clear to the participants or to the readers that that this image will speak 1,000 words. That was not available for semiconductors, and the reason for that is, again, doing anything in semiconductors is, it's not easy, because there are a lot of physics involved, a lot of complex equations involved, and these complex equations which actually might actually really scare you, unless it is put up in a very systematic way. So that thing, we said, okay, let's try to work on this problem statement, that let's try to structurize, or let's try to put a lot of graphics in semiconductors, so that it becomes easy for our students to enter into this particular field. The entry barrier, entry barrier, mostly in semiconductors, the entry barrier is the complex models. So for example, there is a drain current, there is a volt gate current, and all the equations for those really will scare you. It used to scare me as well, because in my M.tech, when I was introduced to these equations, when I was bombarded to these equations, it was very tough for even for me to grasp those. Being an M.tech at IIT Bombay, it was tough for me. So it will be definitely tough for a third year or fourth year engineering student. So that was the key problem. There were a lot of content. Content was available. It was not in a presentable format. So we just took the available content on the web, and we do our own graphics. The way we do our own graphic, we have basically put that graphics in the semiconductor content. Again, it was very tough. It was not easy to make those graphics for semiconductors. To explain one topic, let's say not even one topic, to explain one line of a textbook, we used to take about 12 to 15 slides just to explain one line. And that way we started. So now we have got close to 5,000 slides, just to explain the entire semiconductors per se. So that much amount of slides and graphics was needed to explain this particular topic, and nobody used to do that. So with those graphics, now it has become at least a little bit easy or a little bit interesting for the students to get into this particular field. They're no more scared of the field, because now they understand piece by piece. They are able to visualize things, and with the help of AI, we are able to even add more amount of visualization. So that's making things easy for us. That's how actually the journey started. It was never the content of what we used to prepare, that was never meant for public usage. We made it for ourselves. I mean, me and my friends, we actually made it for ourselves. But when we posted it on our website just for fun, IIT Bombay, a lot of IIT Bombay juniors, they got placements in analog devices, Synopsys, Cadence, and all these companies. They were started getting placed. That's where it all started online. That's where we started to put a fee to the entire content, and that's where the business actually started.
Okay.
Yeah.
That's very interesting to hear, and I'll definitely recommend this resource to my peers. So a lot of students around
Yeah.
me have this misconception. Maybe it's true, or it's a misconception, that if you're trying to become a hardware engineer, it's necessary that you do get a master's degree, whether it's from a reputed institute in India or abroad. What do you think about this particular idea, and what have you experienced yourself?
Yeah, so masters, what I've seen, at least in India, the top 7 institutes who provide MS or M.tech, or MS from outside India. I always generally recommend, if you want to do masters, do it from these colleges, because these colleges have got the fab available, readily available. And there are some other universities, like but there is one in Hyderabad who have got a fab setup. So there are colleges who have set up a good amount of manufacturing labs in their college campus. For me, why it is currently for me to understand or to connect the entire chip design from hardware to software, because my background has always in physics and into manufacturing. I was into lithography. Electron beam lithography was my M.tech project. So lithography is a technique where you have this final you have the chip already designed, and once the chip is designed, the output of the design chip is nothing but it's nothing but a graphical data stream, information integer. It's called a mask. It's like a photo mask, and that particular mask gets printed on the chip, and that's how your chips are basically designed. So my job, my M.tech was to optimize the light, the photolithography and the electron beam lithography techniques. That was kind of my M.tech. Now, to get into semiconductors and VLSI, these things are also needed. You need to understand. You need to see manufacturing and all, to understand the core of VLSI. For example, if I want to teach you VLSI, I myself should be aware of of how it gets fabricated. Does the not just the theoretical view of fabrication. I should see the systems and all, and that way I will be able to make you understand VLSI in a much more better way. So, and these facilities right now, at least what I have seen, IIT Bombay has it, IIC Bangalore has it, and IIT Madras was just building when we were working there in 2018-19. We had seen IIT Madras also building a fab. So any institute which provides a fabrication facility, better to do M.tech over there, so that you get a clear vision. Now, it's difficult to get into IITs and ISCs and MS. So there is an option called as a design. The design jobs are readily available, but to enter into design jobs, the 9 months to 12 months of time span that you need to spend for preparation, that is something which is non-negotiable. That has to be spent anywhere, either to spend that time in institute, or doing MS, or doing M.tech, or any place. But at least that 9 to 12 months of time which needs to be spent, that is well spent in M.tech, because you get a degree, and that is and if you go to these institutes where they provide the entire workflow, but it has to be a good reputed institute, like CDAC, for example. CDAC does a very good training program on semiconductors, 9 months to 12 months of program. Then there is a government organization, Safal, in Karnataka. They do good programs. So it has to be government recognized programs. They should be connected to the good partners. They should be that 10 months you can spend either outside doing your own studies, but through these institutes you can self-study, or you can do it from MS. Anything is fine, but 10 months has to be spent.
Okay. So just to put into context, the gap that you mentioned between the academic degree and actually getting a job at the industry level. So I'll explain what I see as a student, because I'm an electronics and telecommunications engineer. So VLSI course or the VLSI subject, that's part of my syllabus. So what we do as part of the lab is that we work on VHDL modules on the Xilinx platform. And so basically we can write basic code structures for, let's say, the ALU or shift registers, FIFO. So these basic things. And then we can program it on an FPGA. But that is pretty much the extent of the laboratory course that we have. So how much do you think upskilling is required from this level to a student getting a job? So can you tell us what this gap that you speak about, what does it consist of, that we are not able to learn at a college level?
Correct. So now the curriculum just spoke about again pre-pandemic and post-pandemic. There is a difference. Pre-pandemic, whatever topic you have learned, that would have definitely got you a real job in semiconductors, and we would be trained within the company for 6 months. Those facilities was there pre-pandemic. Post-pandemic, because of so much content available on the web, anybody is able to do what a college is teaching as a part of the VLSI curriculum. So that content or material is actually available to everyone and anyone. So there is right now there is no competition between a person who is doing PhD in a college and a person who is doing PhD outside college. So there is actually literally the bar is now straight between tier 1, tier 2, tier 3. I mean, there is no tiers because the content is available on Coursera, on Udemy, everywhere. Now, what extra will make you different compared to the crowd is there are few key topics which actually industry is looking forward for right now, because they assume that all the fundamentals are already self done by a student, by a participant. And what is the extra thing that they need to actually work on? One is SoC design is something is a real application. At the end of the 9 months, or at the end, your program should end at a real SoC chip which is ready to be manufactured. That is what one of the important things that industry looks for. Second thing, even if for FPGAs, if you're building an entire system on FPGA, on top of whatever small projects you have done, like shift registers and ALU and all of it, but if it is ending like a real project, for example, Shakti microprocessor, IIT Madras, Shakti microprocessor in core, you must have heard of the company in IIT Madras, the Shakti microprocessors, Professor Kamakoti. That was actually a project. It was actually a PhD project that now got converted to company. So the PhD projects, the one project that the founder did, he actually built an entire system on FPGA. So on FPGA also, if you are building on a real system, and that again takes 9 months. The 9 months, as I said, is completely non-negotiable. That takes again 9 to 12 months of time to build a real system on an FPGA itself. So if you are choosing FPGA, if your college is choosing FPGA, if you come out with a real system which actually solves a real problem in the industry, that still works as a very good project in the front end side. The backend side, replace that particular FPGA, the whole board, as a single chip. It's basically called as an SoC. So if you have a content or a curriculum or a lab that finishes the whole thing as a real chip, that also becomes a very good. That's the gap that I'm talking about. Third is there are programs which allows you to manufacture this particular chip using some of the open or free programs which was used to sponsored by Google and eFabless a few years back. So our company also took advantage of that particular shuttle, where we manufactured 65 chips, 65 design projects from students. The students were from semester 3, semester 5 and semester 7. They actually manufactured real chips. Again, it was the 9 months, 12 months of time was spent on manufacturing those chips. So these are some of the key skills that industry looks for, because once in your resume it comes that you have manufactured a 130 nanometer RISC-V chip. That adds a value. If your resume says that performance characterization of ARM processor on FPGA, that also adds a real value. Built an associate system with certain PPA value. These are the topics which plays a real role in the resume. So this is what is differentiating right now the current gen. The current gen is actually doing it. If you look into the profile of the students that is there under VSD, all the products that you see listed under VSD brand name, they're all built by students 6 years back. Now they're working as engineers and lead engineers in company, but they were actually, when these products were getting built, they're always built by students. That is right now happening as of today. And post Chat GPT, things have actually speeded up. We are getting some good amount of good designers who are taking full advantage of the GPT, of the AI, and building good analog designs. So those things are right now happening. So these are and then the gap is now even going to increase right now, because if it took 9 months to do one project pre Chat GPT, it will now take about 3 to 4 months to do the same project with the help of AI and Chat GPT. And the 4 months can be done for something else. So the gap is even going to widen unless students starts adopting to GPT and AI for their current projects, and at least the mundane task can be pushed to AI, and they can focus on building systems and then focus on designing the whole system rather than writing codes and things like that. So yeah, these are the gaps pre Chat GPT and post Chat GPT.
That's true. That's true. There's a big difference pre and post
Yeah.
ChatGPT. I think a lot of people speak about pre and post pandemic, but I think the differentiation that you made here, pre and post ChatGPT, is actually much
Yes. Yes.
much more significant, especially in terms of what students are able to do.
Yeah.
Uh, Having spoken about that, I went to your website and I saw that there are multiple different courses available on your website. So how did you bifurcate that these are the courses that I want to put out? And could you give us like a brief overview of the kind of courses that you have and how each of them is relevant to a student audience?
Yeah, so the courses were built based on what was the current industry need. So when, for example, whatever courses that you saw on the website, that was made, you know, that was made in days where we anticipated that 5 years down the line, this will become the main point of discussion in the industry, and that actually happened because. Most of the some of the courses were built by experts, and these experts were uh, someone like who did something out of the box, and they were in the research domain in some of the companies, and then we teamed up and we tried to put around things which their research will become relevant 5 years down the line. So we knew that this is going to happen. For example, open source EDA, that did happen. Now everybody is talking about open source. Risk 5, when we started building courses on Risk 5, we knew it is going to come, and so that's why now you will see a lot of words and talks about Risk-Fi, and we were already prepared for the Risk-Fi. We are already prepared for the Risk-Fi topics. Anybody asks us for Risk-Fi, it is already there. So this we just envisioned ourselves like 5 years down the line, what is going to be relevant, and based on that the courses were made. It was relevant in those days as well, but those were like high paying cost in those days, high paying jobs in those days. But now those jobs are like, and everybody will be able to do those kind of jobs because the courses were made in that particular way. Now next we are predicting that 7 nanometers, the technology, 7 nanometer technology, that is something in the next 5 to 7 years it is going to take place. It is going to become more relevant for the kind of systems that the companies are designing. Again, post ChatGPT, if you want to run a real a GPT kind of software on a phones, on hardware like phones and all, the phones needs to be very fast, and the only way to make them fast is to design chips using a technology which is much more faster, and 7 nanometer technology basically allows you to do all of it. So next 5 to 7 years it will be mostly FinFETs and 7 nanometer. So the courses and the content for 7 nanometers has already begun. We have started to make those. I think while the old courses that we have, that will be still relevant because fundamentals don't change, and we are focused mostly on the fundamentals part. But the upcoming topics will also be coming in. 7 nanometers, FinFETs, and all is going to something shape up the content that we currently have. So it's all visualized. It's all we have to see 5 7 years down the line, and then start working from day one. So that's how everything was actually built. For example, we started making online courses in 2011, and 2011 nobody used to nobody used to do online. They didn't like the online model. They used to like the classroom brick and mortar case. But the moment pandemic hit, 2018 19, when the pandemic hit, everybody wanted to go online, and we were already prepared. We are 9 years ahead of the market. So that's where we got a lot of business during 2018 19, because online was something which some of our peer partners in US and other places, they were already doing it. For example, EDX was already there, edX was already there, and there was Coursera was already there, Udemy was already there, but it didn't, it didn't, it was not very much aware that it is going to take a good amount of shape. But for us, we already looked at in the, we envisioned that online is going to be there because people like us, people like me who don't want to go to classes and all, because I hate sitting in a table and chair for 1 hour and listen. So people like me, and there will be many people like us, the lazy people. Lazy people like to watch things on their mobile phone, and for so online was built for people like us. And 2019 and all, when the pandemic hit, everybody had to move to online. So we were already ahead, And that's when we decided, we started making courses on the other topics which will be relevant 4 to 5 years down the line. That was open source at that point of time. So open source, RISC-V were the topics that will be relevant today. So the courses we started making them 2018, 19. We designed chips, we manufactured chips, and now those courses are very much relevant. In fact, that is the reason we are talking right now, because you got to know about us because of these things. So that's how we have been preparing our content based on what will be needed for the future.
That's true. That's true. I think what's really striking about your answer is the foresight that you mentioned. As an educator, as an entrepreneur, that foresight is very important. Can you tell me what difference do you see between being an engineer and being an entrepreneur? And how do you manage having your own company that's working at this kind of scale today?
So, since our journey has always been engineering, entrepreneurship was just an outcome of what we did. We never focused that it has to be an entrepreneur, or it has to be a full time job. My full time job was even much more safer and excited than my entrepreneurship circle, because I knew what we had to do, and what was the paycheck that was coming at the end of the month. That was pretty much defined over there. Over in entrepreneurship, it's totally it's totally reverse. We don't know what we are going to get at the end of the month. It might be high, it might be low, it might be nothing. That sort of uncertainty is there in entrepreneurship. But the passion, the excitement was the same while I was doing my job, and while I'm doing my entrepreneurship, because the topics that really we wanted to work on, I used to work on those topics while in Qualcomm and Cadence, and I still work on those topics, those problem statements while in entrepreneurship. So what we feel is that we have to just give our 100% on solving the excitement problem statement, and then the money and the business automatically comes. It could be entrepreneurship, it could be job, it could be anything. As long as you're solving a problem that impacts thousands or millions of people, the money is there. The money is going to come. You can give any name. It can be entrepreneur, it can be startup, it can be job, it can be anything.
That's true. That's true. Coming to our last question. So, I'm doing this interview specifically because I have so many peers who are interested in hardware and who are interested in VLSI design, and yet they really don't see the kind of opportunities that people who've built their skills in software do, despite of putting in a lot of hard work. So, what would be your piece of advice be for these students who are putting in the work, and yet they see that there's more need for effort, there's still a gap? What's your advice?
So the industry right now looks for data. If, for example, if you also go for interview, for example, my students, this particular, for example, this particular board. Now, whenever the one who designed this particular board, whenever he goes for an interview, he takes this board with him, saying that this is what I've built as a part of my curriculum. And the interviewer asks, he doesn't look into the paper resume, he doesn't look into any of what he's writing in a resume. He basically talks only about this particular board. So this is the kind of preparation. If he or she has done this kind of preparation, then I'm very sure there is no company who's going to reject him or her. Now I'll tell you another example. This particular chip, you see this blue chip over here. This gray chip over here. So this chip itself was manufactured as a part of her internship program. She built a 10-bit D2A converter, and there is a D2A converter inside this particular chip. So when she goes for interview, she basically tells that I designed this chip. Now if an interviewer, the one who and she was into 7th semester or 8th semester, and when the recruiter hears that, okay, this is what she has built, all the questions will be around this particular chip, and this is exactly the skill that the industry also needs. So they will and right now the kind of skills, we are getting students who are able to design this particular chip and showcase this. So we are getting that kind of talent as well, and that is, if let's say 100 people join for the program, only 5 people do it. The rate is 5%. 100 people or 1,000 people, if they join for the program, 5% of the ones who are actually completing and getting this kind of outcomes. And industry is basically looking for those kind of talent, because that basically eases up their job of not retraining them and all. So many of the students who have real project to show as a part of their interview, I think there are a lot of plenty of opportunities for them. But if there is if it's just a resume on paper and a simple design and with any without any outcome, it's very difficult to trust whether this project was done by him or somebody else. If there is no data to prove that this project was done by him or her, that could be the one of the major reasons. I'll tell you another example where we received close to many resumes, 80 to 100 resumes over a month. Every resume had got one simple project. There was a design called as Falcon, FALCO, and Falcon. Everybody has done the same design as a part of the resume. Now it becomes for recruiter to really differentiate who, because one project done by everybody, it's very difficult to find out who did the original project. So that is what issue recruiters are facing. So it's a problem on either side. But yeah, if you carry your project with you, if you carry your real project with you, just like all these projects that you see over here, these are all built by students. These are all built by the third year, fourth year students. So if you carry your project with them, then there is no way anybody's going to reject it.
Okay, that's very interesting answer again, because it showed, it show your project instead of just putting it on a resume. I'm sure that's a really, really interesting strategy to implement in an interview, and I think it will also assure the recruiters that yes, this has been done by the student
Yes,
who's claiming to have done it.
yes, exactly.
Right.
That's it.
It was a great honor to be able to talk to you for our podcast. A great big thank you to everyone who has watched this video till the very end. If you think that our content is insightful, please like this video, please share and subscribe our channel. We at IEEE Pune's podcast Beyond Conversations are always striving to bring educational, insightful content to our audience. If you have any suggestions or thoughts, please leave them in the comment section. We're looking forward to bringing a lot more great content and videos and discussions and conversations to you. Thanks a lot.